So we've had this fitting for a long time. It's stainless. This is a transition fitting that's been fully tensile tested. It's a category 1 transition. The transitions into brass with a bronze cap and a brass plug. So this has been out for quite a while. A couple of years ago, we had a customer come to us and say, we want this in a totally plastic version. So we developed this fitting, and this is called the SurTap fitting, and you'll see it talked about in that literature. So the SurTap fitting is designed to hook directly to this valve that we built, and we did a lot of work to make sure that we didn't cross-thread the plastic to the metal and things that blunted the first threads and things that you learn in the process of building something. But there's still applications for the brass component. But we make this 2 to 12 inch now. And the Jameson cammering, the robotics guys, the ULC robotics up here are using that for their cammering and tracer rod connections and some other applications. But in this case, we're going to use the brass. This is an aluminum brass adapter because this is the same thread we use on our high-capacity plastic thread. This happens to be a 2-inch MPT. So we just put this little piece in. I can do it either way. I can't do it. I can't do it through the valve, but we'll do it this way, since that's the way you want to do it. So we can capture this detent and bring this plug out.
The tool's designed to be gas-free, to use gas-free for the tapping of it, rated to 125 pounds, so for the whole plastic range.
But we could do the whole installation live, under pressure.
Under pressure, right.
So what you do at this point, if you obviously haven't scraped this, haven't welded it to the main, and just got it clamped to the main for today's demonstration, but that's what you would do. You do your pressure test at this point. Then you put this device on top of that.
Detect the pipe.
One of the things we noticed when we developed this fitting was we went out to watch it be installed the first time and used with the cammering system. And they were using one of the great big steel valves, with the steel tacking device that's a big crank thing that stands about 8 feet up, designed for steel. And we thought, gosh,
That's good.
that's not what that's not our idea of what we ought to be doing. So this multi-purpose wrench, I'm not going to tighten it all the way today because we're not working under pressure, but ordinarily the pipe doesn't twist quite that easy. So we got, we can also pressure test through these ports. There's 2 ports on either side of this adapter that you can put your gauges and your quick release stuff on. So once we attach that to the fitting, then what we do is we take the tapping tool. By the way, everything goes in that case right there with everything included. You're looking at about 38 pounds. So we pull back this little detent here, screw this on, get it straight, Mike. Then once it gets close, lock it in. So our cutter's locked in, it won't reverse out and be left in the main when we get finished. It's just a little break.
Mike, to just talk about the cutter.
Oh yeah, this cutter's stainless steel, and it's a low torque cutter, so you're gonna go through this plastic with about 35 foot-pounds or less, okay? It's gonna go right through the base of the fitting. It won't, in the case of the 3 through 12, it won't take any of the fitting with it. If you're working on 2-inch, it'll take a coupon off of the fitting as well. We've done full testing, and we know that we continue to pass all the pressure tests required for the larger coupon. Because what we're basically doing is, after this fitting is through, we're cutting away some of the cold zone that's inert at that point. It's not necessary. It's just there to dam up the molten plastic, and once it's done that job, we don't have to worry about it.
It's
So
also
now,
designed shavings.
Yeah, yeah, and we'll see that when I pull it. Yeah, almost all the shavings we're gonna produce are gonna be pulled up into the cutter. Very little, as you'll see when I show you later, it's gonna remain down here. Now we connect this. And you can usually get this to seal just on that O-ring that's at the top with a hand tie. But we've also got the wrench, the multi-purpose wrench that we can tighten. At this point, we're ready to open the valve. We've got the collet nut up here released. Hit the brake that you can't see, the little blue brake that's back here. We drive it down, make sure it's in contact with the fit or with the pipe. Now we lock down that. First of all, I need to make sure that my cutter is completely retracted. We're going to lock this down. The only reason you want to make sure that the cutter is completely retracted is what will happen is if you, especially if you're working on a thick pipe, you're going to run out of travel before you get through. So if this is all the way backed out, it has a positive stop on the top and a positive stop on the bottom. You grab that.
You have a mark on that shaft?
What?
Or you have a mark on that shaft for verification?
No, what we would do right now was we'd put a black mark on the shaft with a Sharpie, just so that we can see that it's not rising as we're tapping.
But any type
As
of
far as
verification
tapping
that you
down, no.
reach the top of the pipe?
Huh?
Or not in any other obstruction?
No, and what will happen is if I don't get any resistance in about 3 turns, then I'm assuming I'm not up against the pipe.
No, you're right though.
But what if you
It is a
bottom
feel.
out on something else? that
Oh,
you
yeah,
think is
yeah,
the
bottom
pipe?
out is a positive stop as well. It'll go through 12-inch, but it won't go through the backside of 2.
All right, you lower the
No,
shaft down.
but you'll feel.
It hits an obstruction.
It's a feel, yes.
It's a feel, all right, so there's no visual indication that
It
you're
takes you
at the
about
top.
2 times to figure out how much of this you should be
Okay.
seeing.
The reason you don't put a mark on the shaft is it's a little different, like with the 2-inch, because you're cutting through part of the coupon of the cup, just a little higher. But in this case, it's almost always going to be real close to where it is right now when you're bottomed out. But you're going to mark it with your Sharpie right here, and if you start tapping it and the shaft starts to rise, you got to tighten this. If it wants to continue doing that, then your cutter's too
No,
low.
you're-
I'm thinking of the scenario where my guy leaves the
Okay,
valve
doesn't-
closed and brings the whole side down and cutter down on top of the
Right.
valve and thinks he's at it.
Yeah, no.
Well, then he's gonna be out like 6-7 inches
And-
more. I mean,
Right.
We sell more
really
valves.
shouldn't-
That's an obvious, right, that's an obvious.
We can sell more valves that way.
Yeah. Just curious if there was any marking on the shaft is all, yeah.
But I can tell you that I'm down against it. This is about the torque that I expect. But you'll see once I get through it, it's gonna be quite a bit easier.
Does the man always rock like that when you do it?
He doesn't usually do it from a tabletop
But
either.
once you make it through, then it gets easy. But that's about the extent of the torque that you expect. We can run it all the way down, and even on a 2-inch, we're not going to be touching the backside of the main. Okay, so now we're certain we're fully tapped. We back it out. And back this up all the way so it presets it for the next time you're going to use it, and it gets it out of the main, so that you don't have that resistance keeping you in there when it wants to. You want to back the shaft out. Now, ordinarily, of course, we'd be dealing with pressure in the pipe, which would help me quite a bit in the raising of the shaft. But we just been not yet.
Yep. You're the expert.
So, hitting this and bringing this back up. What we've got in there too is one of the things we learned early on was if you hit the brake and you didn't have a pressure relief system within it, you would slam that up. But if this were under pressure today, you'd see it go slowly up. So now our cutter is fully retracted. We'll close the valve and remove the cutting tool. The other thing we would have done under pressure, we would hit this pressure release valve to get it makes it tool come off so much easier. We do that. And
Mike, what makes it walk down through the pipe without downward pressure? Is there internal threads in it?
Yes.
yes. So I'll finish this if you don't mind.
Yeah.
So it depends on how many times this code's been used, as to how much resistance I'm gonna get trying to get this coupon out of here. But after it's been used about 2 or 3 times, the coupon gets a lot easier to take out. But we're gonna press the coupon out so that we don't damage the cutter and we can use the cutter. We've got folks that have used the cutter 50 times. And before it gets to the point of where you just, it wants to push the shaft up even against the pressure of the, what I want to show you here is the back side of this.
That looks like a lot of work.
Yeah, well, for a 63-year-old man.
Oh, I was gonna make a
But
judgment.
most ladies at 25 is just fine.
What about a guy wearing T-man socks?
That was the only one left.
One of the things we saw with the other systems that were designed for steel was they were sawtooths, and they would just produce tremendous amounts of sawdust or poly shavings wind up in the main. What we like about this system is that virtually everything's above the cutter. Okay?
So part of their tool comes with this insertion device which puts the plug in, but unfortunately this design does not work with GasComm because we need the extra length of the unit, similar to that I just showed you guys when I passed it around.
So without taking that off, this is the hole that you just produced. Good size hole open to be able to get that tool in.
So in order to insert GasComm, we've come up with a prototype at this point. It's just preliminary, but this is a similar concept to what the folks are generally used to for the steel pipe. What they're doing is they have their tool and they're able to add additional extensions based on the length of the pitot tube that they're putting on, or the GasComm itself. And that's determined by whether they're in a 3-inch, 4-inch, 6-inch, 12-inch pipe. So for this demonstration, you can see GasComm is on here. This is a spring-loaded adapter. This is a TD Williamson adapter. The changes that we've made right now to our GasComm, we've modified the TD Williamson version that we already existed because the threads were the same. Now where the gaskets go are slightly different, so those are some of the tweaks we need to make to the mechanical design of GasComm in order to fit into this fitting. And so because of that, we're using the TD Williamson adapter right now. And that allows you, this is different than say the socket version, because the socket version, there's the risk that you could, the weight of the GasComm could fall off the socket, and that's a big no-no. You certainly don't want that to happen. So this spring-loaded is the ideal approach. We just actually loaned this to Questar when they did their installation. So what we need to do is accommodate in this shaft the length and the cylinder length to get this device to retract far enough inside of here to thread on there.
By the way, that connection is not a foreign connection to you guys. This is a 5/8 swivel that makes that quick connect to fit. And then this is a 5/8 nut. So it's not something that you can't access.
So at this point, you open up the gate valve and you can slide in the new GasComm. This is a new device, so it's probably not glued up quite as well as it should be. And you simply just thread it down. You'll feel it hit the O-rings, and then eventually it will just bottom out.
how do you know if the instrument's properly oriented inside the pipe?
We'll get to that.
That's a good question, because it is a pitot tube, and the pitot tube holes has to be lined up with the flow of the gas.
So this is spring loaded, so if I press down on this and pull this out, I'm now released from the GasComm. When we take this off, I'll show you the adapter that's on there. And that adapter will eventually be removed. You can take the fitting off. Let's take this off first. And then generally you would take this off. Yeah, if you So just for show and tell, I don't know if you can all see this, but this is the Mueller adapter. This integrates with all the existing Mueller tapping tool. They've got a thread here. It's a pretty coarse thread. So when they're done inserting it, when Mike quickly released the bit there, it's the same concept. It'll release from here without releasing or backing out the Mueller device. And then, I don't know if you can see this, I'll take it off. So these all come in a kit. And you can see that this is, see the bottom of the spring-loaded tool. There's this little notch that this thing slides into. You press it and turn it, and it locks it in place. But to answer your question, as far as the alignment goes, we have an alignment tool that's provided with the GasComm kit. And inside of here, so there's separate O-rings inside of here that are independent from this one, so you can align it. There's two lines here, and generally there's an arrow that tells you which way flow should be going. You line it up parallel with the pipe. So I've just turned the pitot tube so that they're in line with the flow at this point. And even if you did it backwards, you would just get negative flow at that point.
So you're done.
Yeah, so it's bidirectional.
Mind if I see?
Yeah, absolutely.
So you said it's got an arrow?
This one doesn't.
Okay. Just because but you would just know the negative readings mean.
Yeah.
It's going the
Yeah, so
opposite direction.
generally after you install the GasComm, we like to do a site verification to make sure A is working and that the flow and temperature and everything are reading correctly.
So based on the position of where the sensor plugs in, right, electronics,
Yes.
would you say?
Yeah, so I know,
It's a signal direction.
I know, just because I know the product, that the flow should be going this way because the connector's on away from you.
It does have an engraved arrow.
Yeah, that's what we're gonna do. This one just does not have that.
Okay.
That's
But
what
it's
it is.
bidirectional flow, so you can tell in either direction.
Be nice to.
Yeah, it's a must.
Does anybody have any questions about this process? So there are tweaks we still have to make. This is all preliminary and demo. One of the things we still need to do yet is, we haven't decided, and maybe you guys can provide some feedback, is in order to accommodate this size instrument, which is for a 12-inch pipe, we don't have enough length in this tube. So one of the things we could do is make a larger tube, but now you're taking this hunk of metal, boring out a lot of material, and it's costly. So one of the things we've come up with is we just make an extension where this threads onto it, and then you thread that onto that. So if you need it, you have it. If you don't need it, you don't need to put it on. It's functionally, it'll help better for packaging and carrying around. But that's kind of where we're leaning towards right now.
That's what we were doing with the steel too.
It is,
Yeah.
it is.
The extenders.
Yep. This one would be all inclusive though. We've often found, like in the beta phase, we've been bringing extra extensions just in case, because we don't know what everybody has on their truck, but generally we find out that they're very well equipped. And I saw you poking around here. This is the completion cap, this is for the steel application at this point.
And you'll make one for this?
Yes, exactly. So you plug your device into here, it's a burial cable, but generally we've been running conduit per your guys' request. But there's a cable gland here, but we now have a fitting that allows you to go from this thread. We're locked into this thread right now because of our intrinsic safety. Next go around, we'll modify the thread, but we do have an adapter that allows you to connect to a 1/2 inch conduit. And you can feed that wire right up through. It comes with a 50-foot cable to your RTO. And that has your intrinsic safety label on it. There's also a label on this one that gets put on there. And this is where the serial number goes, because those caps can go from location to location, so we did not put the serial number or model number on that one. It'll be on here. So there's 2 labels that come with it. That's part of the intrinsic safety